this series of videos, we're looking at Renishaw's Productivity Plus Active Editor Pro software. Active Editor Pro is a Windows-based application that's designed for the programming of Renishaw's spindle probes and tool setters. Its primary use is for setting up parts and tools prior to the manufacturing process. It can also be used to help control that process while it's running. So we've done a lot of programming now. We've programmed measured statements, constructed features. I've shown you how to do a WCS update. We've got enough of a program here that it's actually quite a good time to look at simulation. So it's important to note we don't have machine simulation. So this isn't going to replace other products that might absolutely confirm that the G-code program is safe to run on a machine. What it's designed to do is give you a slight simulation of the features we've measured so you can visually represent it, catch any collisions that might occur around the part, and really just to give you some peace of mind before you go down to the machine and run the program. Okay, so we've got our program we used from the last video of updating a coordinate system, so we'll start with that. Now on this tab here within our design view, we have one that says visualization. So if I click on that, it's a different view. We can manipulate it and move it around as we see fit. That won't change the design view. We have these controls on the top. So first off, we have the speed in which we're going to run the visualization. So I'm going to keep that at maximum. We have a play, we have fast forward, rewind, the kind of controls you'd expect to see. We have this button here, which is pause on collision. So you could switch that off and just let this run. If you've got a very long program, you might want to run it, go get a coffee, come back, and then see if you've had any collisions if you're not going to sit and watch the whole thing. This is obviously quite a short program that doesn't really matter too much, so that's where you can just have this pause on collision. There's also a marker which we'll come back to and I'll show you how that works. So for now, let's hit play and see what we've got. So we're simulating the probe. We can see the marker there as to where we are in the program. And instantly now what we can see is we've had a crash. The probe's been highlighted red to illustrate that. It will also say in the bottom panel here if we've had any collisions. Okay, so let's go back and have a look as to what's caused that collision. So I'm going to go back to my design view. Now, I will admit, I've kind of tricked you a little bit here where I've actually increased the inspection depth to a point that that toolpath now can no longer be visible. So it's now gone through the fixture. So as you can see here, I've got that set to -50. I'm going to change that back to a -5. And what you'll see is that toolpath now is visible. So there's a good chance if we run this again, that collision won't occur. So that's obviously picked that up. You could notice it with the toolpath, but by visualizing it, it's just a quick way and a bit of peace of mind to see that everything's going to be okay. So we'll go back to visualization. Now I know that point was fine, so I might want to select the circle and use my marker. So you can see the probe's now jumped to that point in the program, so we're just going to run it from there. So just to save a bit of time. So I'm now going to hit play. And sure enough, measures that feature absolutely fine. Okay, so now it's going to move across to our other bore, and actually, as you can see there, that's now collided with the edge of the part. So we've got another problem to address here. If I go back to the design view, now the way that Productivity Plus works is we set a safety plane height. And because these two features, as you can see here, one feature over here, they are using the same safety plane height. And what happened is we've got to that, and now we're moving up to the next feature. So we're not representing every single toolpath. That's where the visualization really comes in handy. Now what I could do is I could extend that safe height to above the job, and actually really that's how we should be programming this. We can set our safety plane height to above any fixturing and the job to make sure that any moves between features are safe. So that's one way we could fix this problem. And if I was to do that, I would simply change the safety height in our inspection cycle, maybe make it 100. And what you can see there is that blue line has now increased and actually is increased to above the job. So that would be safe. That's one way. Another way to do it, and not just in the case of the Z-axis, but maybe other axes as well, is we could actually insert an intermediate position. So this is just a position, there's no measured feature there, that we can command the probe to move to, essentially to navigate around the component. So what we'll do is we'll add one here. So after this measured circle, I'm going to click intermediate position. And here I can choose an XYZ position of where I want to move it to. So at the moment, that's moving it to 0, 0, 0. So you can see there, that line's going down to the center of that ball. What I'm actually going to do is I'm going to put in Z100. So after we've measured our circle, and I'm going to highlight these both here, the last point of our circle is this point here, so it's going to then come up and then perform an intermediate move to this point in free space there. So that point is now in a safe position to then go on and move to our next feature. So we've added that in. If I go back to visualization, let's see how that works. So we will select the circle, put in our marker, press play. So successfully probes the feature up to the intermediate position, and then of course across now to measure our second circle. Okay, so that's the visualization complete. We can see now we've got no collisions, so that's going to give you a certain amount of confidence when going down to the machine tool to then prove out your Productivity Plus program. If this video is of interest to you, please visit www.renishaw.com/productivityplus.